Welcome to 16th lecture on computational mathematics with CS Math. In this lecture, we will look at how to plot graphs in 2D using CS Math. So, let us look at. First of all, you can look at this reference manual from CS website. So, for example, it is a reference manual on plotting. So, if I click on this, it will open a reference manual which is says 9.1 reference manual for 2D graphics, and if you go through this is 458 pages reference manual, and this will give you all possible plotting in 2-dimensional space, right. So, you have for example, general 2D plotting, then functions and data, plot of other mathematical objects, basic shapes, and then you also have some graphics array and things like that. So, you can refer to this reference manual for more details. So, let us look at our worksheet. So, first thing is, let us plot graph of a function which is explicitly defined, that is y is equal to fx, and fx is explicitly defined in terms of x. So, for example, let us look at a function fx is equal to x into cos 1 by x, and let us plot graph of this function. We have already seen plotting graphs using matplotlib. So, in fact, you can also plot graphs using matplotlib from CS worksheet itself. Okay. So, let us look at how do we plot this graph. So, first you need to define this function. So, let us define fx is equal to x into cos 1 by x, and then in order to plot this graph, again you can use f dot tab and you will see an option called plot. So, if I say f dot plot, then it will plot graph of this function in the interval -1 to 1. That is the default interval it will take. Since we have not specified any interval here, it will take -1 to 1, and it plots the graph in blue color, and it has some default options. So, you can also give the domain in which you want to plot. So, for example, let us say if I want to plot graph near 0, then we can mention the interval from -0.1 to 0.1, f dot plot -0.1 comma 0.1. So, this is the graph of the same function in the domain -0.1 to 0.1. Okay. So, you can also plot graph of the same function using plot function, and inside that you give the name of the function and then give the domain inside round bracket. So, x varying from -0.1 to 0.1. So, that is another way of plotting graph. Okay. Now, you can change the various options of this graph. For example, you can change the color, you can change the plot style, you can change the thickness, you can make grid lines, all such options also exist. So, you can for example, look at help on a plot. So, if you say plot and then question mark, then it will open an inbuilt help manual, or you can say double question mark. So, you can go through the help document on plot, which will also tell you what are the other options that you can use along with plot. Right. So, suppose for example, if I want to reduce the figure size, by default it gives you figure, let us say like this, which looks quite big on the screen. Suppose we want to reduce the figure size, you can mention the width, you can mention the height. Let me mention only one parameter for the time being. I can say fig size equal to 4, and then it will reduce the figure size. So, depending upon what size do you are looking for, you can change the size. You can also change the color. So, suppose if I say color inside this plot, if I say color and inside single quote green, or you can also give double quote. If I say green, then it will plot in green color, right. So, this graph is in green color because we supplied this option green. Now, suppose you want to also put grid lines. So, you can say grid lines equal to true. Grid lines equal to true will add grid lines. Of course, it will put grid lines, default grid lines, but you do have an option to put grids at whatever interval do you want. So, you can look at plot options, help on plot, and look at how you can change the grid lines. Okay. Similarly, you can give more options. So, for example, if I want to reduce the thickness, by default the thickness is 1. If I let us say thickness is equal to 0.5, then it will reduce the thickness, and let us say we want to plot line style like dash. So, it will plot dashed line style, and you can also mention the title. So, here the title is graph of x into cos of 1 by x. So, that is the other options. So, you can see here this the thickness has reduced. It has also given the title of this graph, and it is also plotting in dash line style. If you want dotted line style, you can mention colon here inside this line style. You can say colon, and then it will give you dotted line. So, let me just to visualize it properly, let me give the thickness, the default value, which is 1. Now, you can see here this is the dotted, right. So, you can explore other options inside this plot and do all kinds of annotations. Now, suppose you want to plot multiple graphs in the same window. So, for example, we have plotted graph of y equal to x into cos 1 by x, and suppose inside this graph we want to add graph of y equal to x and y equal to minus x. How do we do that? So, this is again very simple. One way to do is first plot this graph and store it in f. So, plot f from minus 0.1 to 0.1, figure size is 6, the color is green, and we will also put a legend so that we can distinguish which curve represents which function. Okay. So, that is the legend label. So, let us store the graph of the function f x in P, and then let us plot graph of x. This function is x, and this is in red color, and label is y equal to x, that is in P1, and then in P2 let us plot graph of y equal to minus x, and this in black color, and the legend is y equal to minus x. Now, what you need to do is just write P1 plus P2 plus P3. So, what it has done is it has plotted this graph and stored in a variable P, in an object P, and similarly P1 and P2, and when you add all these things together, P1 plus P2 plus P plus P1 plus P2, it will give you the graph of all these functions together. So, that is how the graph looks like. So, this is red is y equal to x, and black one is by y equal to minus x, and this green one is y equal to f of x. That is the legend. Again, this legend you can change the position of this legend depending upon the space. So, for example, if I want to reduce the figure size, I can also ask it to show, and then in the bracket I can say fig size is equal to, let us say, 4. So, then it will reduce the figure size. You have an option to give figure size inside plot, or you can also give figure size inside show function. Okay. Let us look at the next example. Suppose you have functions which are defined in pieces, what we call as piecewise defined function. So, for example, let us say if I have a function f x which is 1 plus x cube in the interval 0 to 1 and 1 plus x in the interval minus 1 to 1, and we want to plot graph of this function. So, it has an inbuilt function called piecewise. You can look at help on piecewise, question mark, and the way one needs to define is you have to define all the pieces inside square bracket, that is you have to make a list. So, and then the first part is the first component, which is between 0 to 1 it is defined as 1 plus x cube, and in the second second piece it is defined as from minus 1 to 1 it is defined as 1 plus x, though here it is written as square bracket minus 1 to 1 and here it is 0 to 1. So, this is open bracket, right. So, here also one should make these changes, or let me write here also 0 to 1. Okay. So, that is the function which is defined. Now, okay, so I think there is a problem, because at minus at 0 it is defined two different values, that is why it is a problem. So, let me define this as 0 to 1 itself, and then how do we plot this graph? So, you can simply say f dot plot. So, it will plot graph. So, you can see here from minus 1 to 0 this is this component, and from 0 to 1 it is this component. So, that is how you can define piecewise functions and you can plot its graph. Of course, if you try to plot between, let us say, minus 2 and 2, then it will not work because this f is not defined outside minus 1 to 1. So, that will give you an error. You can see it will give you, it says that these points are not in the domain, though it is plotting. Okay, so let us make it from minus 1 to 0, right. Okay. So, similarly, suppose you are minus 1 to 1. Suppose you want to define a function which is defined in 3 pieces. So, let us say you have an example f x which is equal to minus 1 between minus 1 and 0.5 equal to 1 minus x square between 0.5 and 1.5, and 2 x cube minus 3 between 1.5 and 2.5. So, again you can define it in a similar way as we have done here. You have to have one more component, but you can define them separately and then combine together, that also you can do. So, I have defined f 1 is x is equal to minus 1, f 2 x is equal to 1 minus x square, f 3 x is equal to 2 x. So, this is 2 x cube minus 3, and then you say f is equal to piecewise, and in the first, this is the first component, the first you need to give the interval, and then the f 1, the next one is the second component, and the third component, and everything is defined inside a list. So, it is a list of each pieces, and then we can simply say f dot plot and from minus 1 comma 2.5. So, that is the graph of this function. Now, you can see here this let me plot only up to 2, so that this will look slightly better. Okay, this is slightly better, but you can see here from this piece to this piece there is a jump, and that jump is indicated by this vertical line, though vertical line is not part of this graph. So, there is a way to says that do not plot these vertical lines. Similarly, this vertical line and this vertical line, you can suppress these vertical lines, and the way to do is you can mention exclude. What should it exclude? It should exclude the points at 0.5 and at also at 1.5, and then if you plot this, then you will not see these vertical lines. That is what you can see here. So, those vertical lines are gone, only these pieces are shown, right. So, you can also for example, plot graph of floor function, right. So, this is the greatest integer function, right, and so this is the graph of greatest integer function, this also known as step function, and inside this we can plot graph of another function which can get inserted inside this. So, what is that? I have this is the graph of this floor function, floor x from minus 5 to 5, and f 2 is a graph of floor function from minus 5 to 5, and with this condition f 2 exclude this integer points from minus 5 4 to 5, that this will include exclude the integer points. That is why you do not see these vertical lines. And then what you need to do in F2, you are inserting F1, graph of F1, and you need to mention the position. This position will be in terms of scaling factor, in terms of x axis, y axis, and height and width. Okay. So, if I plot this in this main plot, that is this step function, it is inserting another step, graph of step function. Okay. So, and you can insert maybe one more. So, maybe try to insert something here, and as an exercise, try to insert, let us say, graph of ceiling function in this particular region. Right. Now, suppose you want to define graph of function which is implicitly defined, y and x are defined implicitly. So, for example, let us look at this example. We want to define or plot graph of a function which is defined by x to the power n plus y to the power n is equal to 0 is equal to 1 for various values of n, for various values of n. Right. So, for example, if n is equal to 1, it will be x plus y equal to 1, which is straight line. If x equal to 2, x square plus y square equal to 1, which is a circle, and things like that. Okay. So, let us look at how we are going to plot. So, first we will define this x and y as two variables. So, earlier we had y equal to f of x, explicit function. Now, I have implicit function. So, y is also a variable. So, first we need to declare x and y variables. As I said in the last class, x by default is thought of as a variable in SAGE. However, it is good idea to redefine that, because in case you have stored x as some value, then it may conflict. So, now let us say we want to plot for n equal to 1 and f of x is equal to x to the power n plus y to the power n minus 1. This is minus 1, and then implicit underscore plot, that is the name of the function which you can use. So, again you can see here implicit function, this is a combination of two words, and in SAGE math this is defined as it is combined as giving underscore in between these two keywords. So, the what are the arguments? You plot implicit underscore plot f, x varying from minus 2 to 2 and y also varying from minus 2 to 2. Color, I am just taking another color called rosy brown, and there are several colors which are available. I will show you in a minute, and let us first plot the graph of this function. Okay. So, that is the graph of the straight line y equal to 1. Now, suppose if I say instead of 1, if I take n equal to 2, it will be a circle. If I take n equal to 3, then let us see what we are going to get. We will get this kind of curve. And if I take for example, n equal to 4, then this is not a circle, but it is a square with rounded corners. And if I take n equal to 4, n equal to 5, then again you will see this curve. So, that is how you can plot this implicit curve for various values of n. For example, if I take n equal to 100, now in this case it is almost like a square. If I take 101, then it will be again open curve, right. So, you can explore various values of this, and of course, you should try to see why you are getting graph when n is even, you are getting closed curve, whereas when n is odd, you are getting not a closed curve, right. So, suppose we want to plot for example, graph of this for n is equal to 1 to 5, all this together. So, we can use simple for loop. So, we can again define the variable x and y, and let me create a empty list, and inside this list we will keep on adding this plot for n equal to 1, n equal to 2, n equal to 3 up to n equal to 4 or n equal to 5, let us say. So, let us say we want 5 up to 5. So, for I in range 1 to 6, let us say I equal to n, f of x is defined like this, and then the same thing which we used earlier, inside this we are saying p is equal to implicit plot this. The color is taken from this color list. I will show in a minute what I am doing, and then you append this in the PLT list, and then at the end you sum all of these together. Then you will see this all these graphs together. So, you have for n equal to 1 straight line, for n equal to 2 it will be a circle which is in somewhat in light blue color. So, it is not visible. Let me change this something here. Instead of this I will make it, let us say 10, and then see whether it improves. Yes, now you are able to see the circle also, right. So, if you want to make use of different colors, there is an you can look at colors, and these colors are defined as a dictionary. So, you can see here by default this is the color, and then you have various colors like antique white, then you have there are so many colors, corn flower blue, dark blue, there are so many of them. Now, there is I think about 100 colors, more than 100 colors are there, right. So, you can go through this list and make use of whatever you want. So, that is what exactly I have done here. So, we taken the keys of this dictionary colors and then converted into that keys as a list, and then we are using 10 plus I square. So, 10 plus I for I equal to 1 it is 1. So, it is we are taking the 21st one in 11th one in the list, then I square equal to 2 for I equal to 2 it will be 4. So, 14th one, 10th one, 14th one, and then it will be next one will be 19th one, and things like that, right. So, that is how you can make use of different colors. Now, suppose you want to define you want to plot a function which is defined by parameter. Let us say for example, we want to plot a graph of a function which is defined by parameter t, and x coordinate is t into sin 1 minus t square, y coordinate is t into cos t square, and t varies between minus pi 2 pi to 2 pi. How do we do that? So, there is an inbuilt function called parametric plot, and again we will declare t as a variable. So, inside parametric plot, now you have to give the each coordinate, namely x and y, inside square bracket. So, you make a list of x coordinate and y coordinate, and then mention what is the domain of t. It varies from minus 2 pi to 2 pi. Color is red and thickness is, let us say, 1.2, and let me also add a text inside this the plot, and that I am calling so there is a function called text, which and the name of the text is, let us say, nice plot. That is, this is the nice plot will be added inside this plot, and the coordinate at which this text will appear is minus 4 comma 4, and then you ask it to show t plus txt, figure size is equal to 5. So, let us see what the curve we get. Yeah, that is the very nice curve, and this is nice plot is added here. Okay, so that is the annotation. You can add arrow, you can add line, you can add points, all these things can be done very easily and very efficiently. Similarly, suppose you want to have a plot graph of a function which is defined by polar coordinates, right. So, here r is equal to, the function is r is equal to 1 plus cos s theta, and s can take values, let us say 1, it can take value 1.01, 1.02, 1.05, 1.5. So, for some of these values we will try to plot graph of this function, and theta varies between 0 to 200 pi. So, let us see how we are going to plot. So, in order to plot polar graph, there is a function called polar underscore plot. So, here instead of theta, I am defining this variable as t. If you want, you can define this as theta also. Let us say theta, and so here wherever you have t, I have to say theta. Here also theta, right. And so, polar plot, and then you need to give the right hand side of r, which is 1 plus cos of 2 times cos s I am taking as 0.5. So, let me make it s here, and I will define s is equal to so to begin with s is equal to 1. let us say s equal to 1, and then thickness is 0.2. So, make it or let me make it thickness is 0.5, and when you actually when SAGE plots graph, it actually plots the number of points and then joins. So, here I am saying that in order to make this plot smooth, we are taking about 5,000 points. By default, it may take about 200 points or 100 points, one can find out, right. So, let us plot the graph. So, this is how the graph of this function looks like. Let me reduce the figure size. So, fig size is equal to 4. Yeah, now it is much better. So, this is graph of 1 plus 2 cos theta, 1 plus 2 cos theta. This is the, suppose now s instead of 1, let us make it 1.01, and then the graph is completely different. Okay, you can see here what is the change it has done, and if I say 1.2, this is how it looks like. If I say 0.03, this is how it looks like. If I say, let us say 1.2, that is again completely different, and if I say for example 2, so that is the graph. So, you can see here for small change in s, the graph of this function looks completely different. So, this is advantage of using this kind of software in order to plot graph with some parameter. By hand, you will not be able to kind of visualize so many things. Okay. So, you can look at help on polar plot and see what are the other options it supplies. Let us look at one more graph. This graph is a graph of a polar function, which is defined as 0.5 into cos 4 t. So, let me make it again in terms of variable t, it will be much better. So, it is not confusing here, t, and then yeah, and this also here t, right. So, this also here t. So, what is this graph? So, let us plot and then we will see what graph does it create. Okay. So, this is the graph. So, you have two graphs actually, two curves, two polar curves. Let me again reduce the figure size. Show this with fig size is equal to, let us say 4, right. So, you have one blue curve and one is red curve, and the red one is for example graph of the polar function r is equal to 0.5 into cos 4 t plus 2.5, and the blue one which is inside, that is actually cos 4 t plus 1.5. So, it is actually just shifted, and then there is a filling. So, it is filled, the two curve in between there is a filling, and the filling color is light blue, that is what it means. So, when you plot graph of a function, there is also an option to fill, which will allow you to fill the area between two curves. So, when for example, when you want to explain or study, let us say area under a curve or area between two curves, you can plot such graphs and using this fill option, right. So, that is just something went wrong. Oh, right, this is I think let me call this as, for example, let us say gray. Yeah. So, this is the okay. Next, let us look at how we can plot a region. So, if you have to plot, let us say region between x y lying between minus half and half, there is a small typo here, the x into y between minus half and plus half. and let us say take x value between minus 2 and 2, y between minus 2 and 2. So, how do we plot that? So, there is an inbuilt function called region underscore plot, and inside this the two curve here, first curve is x y is greater than equal to minus half, and then second one is x y equal to less than equal x into y less than equal to half. So, that is the first curve, x into y less than equal to half, and other one is x into y greater than equal to half, x varying between minus 2 and 2, y also varying between minus 2 and 2, and in color and out color there are two options here. So, let us plot and then we will see what is the meaning of this. So, when we plot, again let me reduce the figure size, fig size is equal to 4 is equal to, you could mention for example 4 comma 5. So, on x scale it will be 4, y scale it will be 5, right. So, this is, let me make it 4 itself. So, that yeah. So, what is it doing? It is inside this it is plotting in red color and outside this in light blue. So, I mean I can say light green and then inside this light green, outside this light blue, that is the meaning. Of course, you could add the curve also here. So, if you want you can create another one plot for x y equal to half and other one for x into y equal to minus half, and then put it in different color, that also you can do. And you can take help on region plot question mark or double question mark. Double question mark will give you detailed help. So, if I say double question mark on region plot, then this is what you get. Okay, so, you can see here, this is the source, this is how the function is defined, and these are the options. By default inside color is blue, out color is none, and border color also you can mention border color. So, for example, if I mention here border color, so if I say here, let me put it here, border color is equal to, let us say black, then you can see the border is now black, right. Okay. And so, there are many other options inside this aspect ratio, frame. If you want a frame, by default frame is false. If you want to plot this inside a frame, you can mention the legend color, and this is how the function is defined, region plot. This is some documentations. This is what you get when you give question mark, and at the end it will also tell you how this function is defined. Yeah. So, that is the body of the function. Okay. So, right, correct. Similarly, let me show you plot of another region, which is x into x minus 1 into x plus 1 minus y square greater than equal to 0, x lying between minus 3 and 2, y lies between minus 3 and 3. Okay. So, that is the region. So, you have here this closed region and then this is outside region. Let me again reduce the figure size, fig size is equal to 4, you can see that is the. Similarly, you can also plot graph of a polygon. So, suppose I want to plot a graph of a polygon, and all you need to do is mention the corner points. So, here minus 1 1 1 minus 1 1 0 0 1, and the color is in gold and red and edge color is black. So, it will plot this is a trapezium, right. Similarly, you can plot, let us say we saw in case of matplotlib, we could plot graphs side by side in a matrix form. So, here also that option is there. So, suppose let me first run this and then I will explain how it is being done. So, you can see here there are 4 graphs, this is one graph, 2 graph, 3, 4, And how it is done? So, it is done using what is called graphics array. What you need to do is you create an array of graphics. So, here we are taking a function f x is equal to sin x, g x equal to sin 2x, and h x equal to sin 4x, and the first one p1 is graph of sin x, the second one is graph of sin 2x, and the third one is actually a parametric plot whose first coordinate is sin x, second coordinate is sin 2x, and the fourth one is graph of again the parametric plot whose first coordinate is sin x and second coordinate is sin 4x. The color are taken as red, green, blue, black, and then you create a list of all these graphics which you have created p1, p2, p3, p4, and then put it inside graphics array, and you need to mention what should be the dimension. So, here dimension is 2, which is 2 by 2, and then you simply say ask it to show. This gives you the graph of these 4 functions together, the 4 graphs together. First 2 are explicit functions, second two are parametric plot. So, and you can create as many as you want. Okay. So, these are some of the standard plots generally we come across in 2 dimension. In the next lecture we will look at how to plot graph of a function in 3 dimension. Some of the standard plots we will see. Okay. So, I will see you in the next lecture. Thank you very much.